We're solving systems of linear inequalities by graphing and shading and looking to see where we have an overlapping shaded area. This is Unit 5, Day 4, continued video notes. So when we are solving a system of inequalities, we're going to graph our boundary lines, and we do that by rearranging our statement so that it's in y equals mx plus b format. So I'm going to start with my upper inequality statement. I'm going to rewrite it over here. I'm going to go ahead and subtract 2x first. So I have 6y is greater than or equal to negative 2x plus 6. Now I'm going to divide each side by 6, and so I get y is greater than or equal to negative 1/3 x plus 1. That's my first statement. My second statement, when I rearrange it, it's going to be 6y is less than or equal to negative 2x minus 12. Divide everything by 6. Y is less than or equal to negative 1/3 x minus 2. Remember, as long as we're dividing by or multiplying by a positive number, we don't have to change our sign. When we multiply or divide by a negative number on both sides, then we do have to change our direction of our sign. So here we didn't have to do that. All right, so I have to make a decision. Is this going to be a solid line or a dashed line? It's a solid line because I have the equal sign included. This is a solid line that I'm going to use. So I'm just going to graph that the way I would graph any. Start at 1, and I'm going to go down 1 over 1, 2, 3. Down 1 over 1, 2, 3. Up 1 and back 1, 2, 3. It's a solid line. I'm going to graph that right here. I might line that up better like that. Okay, now I have to figure out which direction I'm going to shade. So I'm going to use my lovely test point of 0, 0. I do love my test point of 0, 0. If I test 0, 0, come back to your original inequality statement. Don't use the one that you've manipulated, just in case you made a mistake. 0 plus 0 is greater than or equal to 6. 0 is greater than or equal to 6? No way. So that means that 0, 0 is not correct. So that means that all the stuff on the other side of my line is part of the solution to that inequality. All right. Now, y is less than or equal to negative 1/3 x minus 2. I can see that these have the same slope. I can see that these are going to be parallel lines. So we're going to have to make a decision about whether we have any solutions that work for both of them at the same time. I'll start this graph by plotting at negative 2. This is going to be a solid line also. Okay, and so I'm going to start at negative 2, and I'm going to go down 1 over 1, 2, 3, down 1 over 3, up 1, back 3, and I'm going to use my handy dandy ruler. Solid line right there. I need a test point. Okay, I'm going to use my test point 0, 0 and see if that works. Up here on the original statement, 0 plus 0 is less than or equal to negative 12. 0 is less than or equal to negative 12. Well, that's not true. So that means 0, 0 doesn't work for my blue line. And so that means I can't shade on this side. I'm going to have to shade below. All of the points below that line would work for my blue inequality statement. When we look for a solution for a system of inequalities, we are looking for the overlapping shaded areas. We don't have any overlapping shaded areas, right? It's only pink or only blue. And what that means is there is no solution here, okay? There is no solution. So I don't have any place that I can pick a point and test because there is no overshaded area. So I'm going to say that's not applicable, okay? All right, moving on. If I'm given this system here, y is greater than negative 3x plus 5, y is less than or equal to x minus 2, which points satisfy this system? I'm going to plug in that statement into each one of my inequalities, and I'm going to see if they're both true. Okay, so if I choose my upper one, that's going to be 1 is greater than negative 12 plus 5. 1 is greater than negative 7. That's true. Okay, it works for the upper one. Let's see if it works for the lower one. 1 is less than or equal to 4 minus 2, which is 2. That's true. So this means this guy is correct, right? That works for both of them. I could also graph both of those, particularly if I'm allowed to use Desmos, I can graph both of those, and I can then check that ordered pair 4, 1 and see if it is in that double shaded region. Okay, let's check 6, negative 5. In my upper statement, I have negative 5 is greater than negative 18 plus 5. So add 18 to each side, 13 is greater than 5. That is true. Let's check the lower one. Y, I have negative 5 is less than or equal to 6 minus 2, which is 4. Negative 5 is less than or equal to 4. That is true. So that means this guy works also. Let's check. Up here, my upper statement, I have 2 is greater than negative 3 times negative 3 is 9. Right, so 2 is greater than 14. Heck, no, that is not true. I don't even have to do the second statement. It might be true for one of the two, but it's not true for both of the two. I already know that. So I'm just going to stop there, and I'm going to not even do any more math. Why did I write 2 is greater than 4? Oh, I put an x because that was wrong. That's not a variable. All right, so 3, 4. Here I have 4 is greater than negative 3 times 3 is negative 9. Negative 9 plus 4, 5. 4 is greater than negative 4. That's true. Okay, so it works for the upper equation. Excuse me, the upper inequality statement. Let's check it on the lower. I have 4 is less than or equal to, 3 minus 2 is 1. 4 is less than or equal to 1. No, it only works for one of those two statements. It does not work for both. So it has to work for both. It would have to be in the shaded area of both. And that was only true for one of them. All right, 1, 2. I know that that means 2 is greater than negative 3 plus 5. 2 is greater than 2. Already not true. 2 is greater than or equal to 2, but 2 is not greater than 2. So I'm going to stop right there. And I'm going to pop us over to Desmos and just show you that all of those points could be checked in Desmos too. All right, so I went into the Desmos graphing calculator and I graphed our two inequality statements that we're thinking about. And you can see that when it's greater than but doesn't include the equal sign, it gave me a dashed line. And when it's less than or equal to, that includes the information on both sides. And so, not on both sides of the inequality statement. And so we get a solid line here. You can see that I'm shaded only blue down below here. So if I look at my lower line, that's the shading for my lower line. This is the shading for my upper inequality statement. And so when I cross them over, you can see this darker area is our solution area. So if you look at your notes, you'll see that your first ordered pair was 4, 1. 4, 1 is in the double shaded area. 6, negative 5 was your next point. That is in the double shaded area. Then you had negative 3, 2. So if we look at negative 3, 2, you can see it's not in either one, right? So that didn't work. I have negative, nope, I have 3, 4. 1, 2, 3, and then I'm going to go up 4. So I'm in one of the shaded areas, but not the double shaded area. So that was not a solution. And then finally I have 1, 1, 2. It's actually not even true for the red since that's a dashed line. So Desmos really does work to help you show what you're working on. All right, so we're going to have one final video to go over those last two problems, but thanks again for watching.